Okay, so we're just using these two as starting points. We're just using these two as starting points from where we're going to go today. So we've done problems like the one on the left throughout this chapter. Remember, when you have equal bases, what happens to those bases? They cancel out. So we're just going to set the exponents equal to each other. So we would subtract 4x, and we get x equals 2. The similar property to that with logs is what we see on the right-hand side. If we have logs on each side of our equal sign, and those logs have the same base, just like we're able to cancel out the bases of 3 here, we're able to cancel out the logs here. As long as you have the log of the same base on each side, there's an equal sign in between, you can cancel those logs out. So we just get 2x minus 1 equals 14, and then we would add 1 and divide by 2. So we get x equals 7.5 in this case. So that's the simplest, that right one is the simplest thing that we would do today, but we're using that same idea throughout the day, where if you have logs on each side, same base, those logs cancel, you can just set what's inside the parentheses equal to each other. Okay, so these step it up a little bit, so you can take a moment and write these two down. So, again, we're using the same premise as what we just saw on the other side. The thing is with this, though, is we have 2 logs on one of the sides, but we know how we can condense those 2 logs into make it 1 log, okay? So we're not going to touch, for number 1, we're not going to touch the left side at all. But on the right side, we have 2 logs that are being added together. So therefore, we can make that into a single log and multiply the 2 things that are in parentheses. So I'm going to make this 2 times the quantity of 2x plus 3. And so now, we have the log of the same base, both log base 10s, an equal sign in between. So now those logs can cancel out. So we can just set what's inside the parentheses equal to each other. So we want to distribute. We get 5x plus 1 equals 4x plus 6. And we get all of our x's on one side, numbers on the other. So we would get x equals 5.
Yeah, we were not like the funniest thing to do was like stretch your eyeballs really wide and just try to blink. So
all right, and then example 2. Same idea, but now we're subtracting 2 logs. So since we're subtracting the 2 logs, we would need to divide the x plus 7 by 3. But now that we have that, we have a log on the left, log on the right, same base. So those numbers in parentheses, those logs cancel out, and our numbers in parentheses are just equal to each other. So we want to undo division by 3. We would undo that by multiplying 3. And I have to multiply it by that entire side. So I would get x plus 7 equals 3 times, or I'll do the distributive property right now. 3 times 7x is 21x. 3 times 1 is 3.
I did the opposite. Oops.
And now we can just get all the x's on one side and the numbers on the other. So I'll subtract x and subtract 3. So we get 4 equals 20x, and we divide by 20, so we'll get x equals 1/5. That's our answer. All right, we got one checkpoint problem to do, one to try on your own, then you can work on your practice. All right, so here's our checkpoint 8. It's now the same idea, but now with natural logs instead. So ln of x plus 3 equals ln of 7x minus 23 minus ln of x plus 1. Log properties apply to natural logs as well, because natural log is just log base c. So the left side we're not changing right now. The right side, since we're subtracting, we have ln of 7x minus 23 over x plus 1. Again, the subtracting of logs means you're dividing what's inside the parentheses. So since we have the natural log on both sides, those natural logs cancel out. We are left with x minus 3 equals 7x minus 23 over x plus 1. We have to now solve this equation. So to do that, we would undo division by x plus 1. So we're going to multiply both sides by x plus 1. So that means I would have to FOIL this left-hand side now, because I'd have a binomial times a binomial. So x times x gives us x squared. X times negative 3 is negative 3x. 1 times x is x. 1 times negative 3 is negative 3. And on the right side now, we just have 7x minus 23. We're going to have to get this equal to 0 because we're going to have to SAM factor. So I'm going to do the opposite of subtract 7x and add 23. So that means my right side 0. On the left side of x squared, I combine all my x's. Negative 3x plus x is negative 2x. Minus 7x is negative 9x. 23 minus 3 is positive 20. So as I go to SAM factor this now, I'd be saying what multiplies to 20 and adds to negative 9. 5 and 4 both have to be negative. And then when I set those equal to 0, I would get x equals 5 and x equals 4. Just like the bell ringer, we do need to check our answers. I have to plug 5 and 4 in and make sure that I do not get any negative numbers inside the parentheses. If I plug 5 in, 5 minus 3 is 2, so that would work. 7 times 5 is 35, minus 23, that'd be a positive number. 5 plus 1 is a positive number, so that 5 is going to work. If I check 4, 4 minus 3 is 1, that works. 7 times 4 is 28, 28 minus 23 is a positive number, 4 plus 1 is a positive number. So in this case, I do get 2 answers. So again, all these are kind of the same idea. It's just sometimes you have to factor, sometimes it's just the solving part that is changes. All right, try this one. That's a little tough to see. This is minus. So log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. Try that on your own. Once you have it, call me over, check it, and then you can work on the homework practice, which is page Page 515. Numbers 77 to 91 odd. Okay, so do this first, check it with me, and then you can work on those problems. Alright, you should get x equals 3 is the only answer to your check. Negative 1 would be an answer.
I was confused because you didn't have numerators.
Right, yeah, that's why I was